Testing, 1, 2, 3. All right, hopefully people can hear me and they figured out how to log in. We will start here momentarily. Testing, 1, 2, 3. Testing. Okay, it looks like some people are joining, which is a good sign. Hopefully you can hear me okay. If you can't hear me for some reason, please let me know. If you can hear me, please let me know also. That would be fantastic. That'll help coordinate things. Good. Looks like a lot of people are showing up now. Great. Well, we will get started in just 1 second. Give me a second. Be right there. Okay, sounds like we're here and we're ready to go. Fantastic. Give me one more moment and we will be ready to start the MOOC. So welcome to the 5th MOOC in the Mobile Cloud Computing with Android specialization. This MOOC is nominally titled something like Programming Android or Programming Mobile Cloud Services for Android Handheld Systems, focusing on the Spring framework. But as you'll see, there's really a bit more to it than that. Let me start off this MOOC by discussing what we'll be covering, and I'll also go through the course syllabus to give you a sense of what it is we'll be covering. Please note that the course website is now open, and a lot of the information is up there. I'll walk through that with you in just a second. The rest of the information will be put up later today, and we'll really be kicking things off in full swing here very soon. So, as you might have derived from looking at the title and reading the description of this MOOC, we'll be focusing primarily here on topics related to connecting mobile devices with Android to cloud services. And not surprisingly, there's both a client and a server dimension to connecting with cloud services. The client side, of course, will be on the device, and that will be responsible for doing things like invoking operations, sending requests over to the service running out in the cloud somewhere, and of course taking the results that come back from the cloud and doing something with them. And we'll be spending some of the time talking about the client side. And then of course there's also the server side, where you'll be writing web services, and we'll be focusing on both the client and the server/service side in this particular MOOC. So it'll go above and beyond the things that we've covered in the previous MOOCs. Of course, we will also bring along many of the same techniques we've covered in the earlier MOOCs, things like concurrent programming, communication. We'll be going a bit more in detail in this MOOC on using tools like retrofit to be able to simplify access to web services running out in the cloud. And one of the other things we'll talk about, and we'll start talking about them today in the live lectures, will be accessing structured data on the device using content resolvers and content providers. And you'll get a chance to build an application for the first assignment that will use the content provider and implement a content provider and use content resolvers in order to be able to access information that's stored in a web service using retrofit to access it. Then later in the course, you'll actually be programming the web service side and implementing the server-side logic using the Spring framework. And so we'll talk more about those assignments as we go along. We've also got a lot of other really cool and exciting new things to show. I've been doing some work recently with some of the summer interns we've got here working with us, and we've got some really neat new framework capabilities to simplify writing Android applications that use concurrency and handle runtime configuration changes in a clean and transparent way. So you'll get a chance to learn about all those kinds of things as well. And of course, we'll also be using some examples here with the SQLite database that runs on Android, and you'll also get some experience with server-side databases later on in this MOOC. This MOOC will be a mixture of live and recorded material. I'll be doing the bulk of the live material, and Professor White has a whole bunch of really cool lightboard-based material, so we'll cover that as well. So what I'd like to do now is kind of walk through the course syllabus and talk about what we're going to be covering in the course so that you're familiar with what we're doing. And then we will start off with the first set of lectures, which are going to cover topics related to content providers and content resolvers. So hopefully you can all see this website. This is, of course, the website for the course. And we've got discussion forums. You can see that we've actually already got someone, Gavin from London, has already posted there. Welcome, Gavin. We have the announcements page, which announces this video, and I'll post the other one. We're going to be doing it on Friday this week because we started on a Wednesday. You can also find out information about how to get the source code and various examples, how to set up your development environment for this course. This involves a variety of things because you'll have to understand how to do several things here. Some of this stuff, of course, if you've taken the previous MOOC, should be old hat, but there'll be some new things relating to using Spring. We haven't got the assignments put out yet. I'll be putting the first assignment out later today. We haven't got the first quiz out yet. That'll be put out later today as well. We have the frequently asked questions, which is a lightly edited variant of what we had last time, so that should look familiar to you. Please read it if you haven't read the fact before. Let's talk about the syllabus. So the syllabus starts by kind of giving an overview of what the course will cover, focusing both on the client side and the server side. On the client side, of course, we're going to focus on Android content providers, content resolvers, and SQLite. And then there'll be a bunch of things relating to the server side with Java Spring and other cloud computing platforms such as the Google App Engine. All of these things are available in video form already. I'll show you that in a second. We'll be using lots of case studies to illustrate the various concepts. You can see that we have sort of this optional section 0, which is really for people who didn't take the previous MOOC or who didn't watch the videos from the previous MOOC. This kind of covers things we covered at the end of the previous MOOC on HTTP communication. So this stuff is all kind of optional if you've already watched it. If you haven't watched it, please go back and watch it now because it's important to understand how to do the assignments. The next thing we're going to cover, which is what we're going to cover starting today in the live lectures, is structured data storage on Android devices using content providers and content resolvers. We'll also talk about SQLite, and we'll talk about a whole bunch of cool advanced ways of accessing content providers asynchronously using things like cursor loaders and the async query handlers and so on. After all that's done, then we'll start switching over to the server side, focusing on how you build cloud services in Java, and we'll talk about some of the things related to Java servlets and more powerful capabilities with programming using client and server-side abstractions. Then we'll talk about databases and deploying to the cloud. This is where you'll start learning about Spring and various kinds of databases. And then we have an optional module, some optional material in the end, which you're free to watch or not, depending on how you feel about it. These are a bunch of videos that talk about how you can use patterns and frameworks to implement web server infrastructure. And this is all in C++ as opposed to Java. So that's why we made it optional. But if you're interested in seeing more about the patterns we talk about, you might want to take a look at that. But that's all up to you for what you want to do. Here's the actual set of videos that we've got. uploaded so far. Again, week 1 looks like a lot of videos, but they're really all the videos from last MOOC, so watch them if you feel like it. We will put up the live videos for week 1 here as soon as I've done processing them. Here are the week 2 videos that are pre-recorded, and you can learn more about that by watching them. There'll also be week 2 videos that are recorded live, which we'll do next week. There's some week 3 videos that are pre-recorded talking about Spring and other capabilities like Jackson. There's some supplemental material for week 3 talking about scaling issues and cloud services. There's a bunch of stuff for week 4, which again goes into Spring. And then there's a bunch of week 4 supplemental videos that talk about Google App Engine and various databases and so on. And then week 5 and week 6 are all the supplemental material related to the patterns and frameworks in C++ implementing a web server. So that's kind of a big picture view of the class. As always, we will have 3 assignments. Oops. This obviously needs to be updated. This is not quite up to date. I need to fix this. Ignore the grading and logistics stuff right now. I will fix that here shortly. That's not the right material for that. It'll basically be what we did before. We will have the 3 assignments. The first 2 will be with shells, and then the third one will be a mini project where you'll do the bulk of the work yourself. Okay, so let me go ahead now, and I will start presenting the slides, and then of course I will come back and we will go through the questions that people have. Okay, let's go grab the first set of slides here. All right, that's coming up. Put it into reading mode, share the screen, and I think we will be ready to go. So the first thing we're going to start focusing on in this course will be Android structured data storage. And of course, this is important when you start interacting with web services, because oftentimes you want to store information on the device in order to upload it to the web service. And you also may want to store data on the device that you've downloaded from the web service so that you can run in disconnected mode, or you can have a cache, or you can have some kind of way of synchronizing between information that's stored on your device and information that's stored into the cloud. So what we're going to do is talk about what content providers and content resolvers are, and we'll also discuss some of the key operations. And I'll show you some examples that I've implemented to demonstrate how all these things work. So let's start talking about content providers. So content providers manage access to a central repository of structured data, or at least the way it's access to a content provider is structured. It may be relatively unstructured, but it's provided in a structured way through the content provider. And you can read lots of stuff here about content providers. The key things that they do is they support operations that are called CRUD, create, read, update, and delete. Those are some of the key operations that are provided by content providers. In this context, read should be interpreted as query. So you're actually going to query and get results back, and it comes back to you through something called a cursor, and we'll talk more about that later. Applications always access content providers via something called content resolvers, or a content resolver. And a content resolver is basically a proxy that shields the applications from the details of how the content providers are created and accessed and managed. So they abstract away from the details of the content provider implementation. So it's basically the proxy pattern. One of the things that they abstract away from is whether or not the content provider resides in the same process that the application resides in, or in a different process altogether. And you can control where the content provider is configured to reside in process or out of process via a directive in the Android manifest XML file, much like we did with services, where you could determine whether a service ran in another process or in the same process as the main activity. So that's basically what a content provider is. And the purpose of content providers and content resolvers is to make the application data available, either to the application or to other applications. So basically, they encapsulate the data. They provide a common way of being able to access data. So they sort of enforce a set of patterns that always have the same look and feel, so things aren't random and ad hoc. And they also provide a means of defining certain types of data security. And you can read more at this link about the kinds of security models that are provided to data accessed via content providers and content resolvers. A content provider typically presents data to applications that's stored persistently. It doesn't have to be persistent, and I'll show you some examples that don't have persistence, but it's a very common thing to have the data stored persistently, because that's usually what you're trying to do for things like email, SMS, MMS, contacts, calendar, other kinds of information, various caches and so on, like recent search suggestions, quick search box, all that kind of stuff. That information typically needs to be residing in persistent storage, although there's nothing that requires you to have a content provider store the data persistently. Again, most commonly, though certainly not always, the data that's stored is stored in relational database tables that are accessed via SQL and SQLite, which is the implementation that we'll talk about later. Activities and services can query and modify data that's managed by a content provider. And one of the things we'll talk about later, which I think is really cool in Android, is you can access the contents in a content provider concurrently, either synchronously via things like async tasks, or asynchronously using the mechanisms that come with things like cursor loaders and async query handlers. So there's lots and lots of different ways to access the contents in a content provider. And we'll talk about lots of them, and you'll get a chance to play around with some of these in some of your later assignments. That'll be part of the requirements for the assignments. There's some interesting characteristics about content providers and thread safety that are described at this link. The thing to remember is that by default, a content provider is not thread safe. So if you want it to be thread safe, you have to implement the thread safety mechanisms. In contrast, as we'll see later, again, SQLite database operations are thread safe. And so if you use an SQLite implementation, then sometimes you don't have to think much about the thread safety of your content provider, as long as there's no shared state that could be corrupted by multiple threads calling into the content provider's operations. Not surprisingly, Android provides lots and lots and lots of content providers. There's content providers used in the browser to keep track of the history of searches and bookmarks. There's content providers used for call logs, contact data, SMS, MMS messages that are stored and sent and received. Maps keep track of previous searches. YouTube keeps track of previous searches. All kinds of other stuff, things like books and calendar and other kinds of stuff. Email, all use content providers. So that's a very common thing to use. Now that we've talked a little bit about content providers, which are really the main implementation artifact for structured storage in Android, let's talk a little bit about content resolvers. So a content provider is always accessed via a content resolver proxy. And the content provider itself actually isn't created until a content resolver tries to access it the first time. And of course, that uses the activator pattern that we've talked about before in order to create the provider on the fly, on demand. The content resolvers manage and support the content providers. So one thing that you can do with a content resolver is enable a single content provider to be shared by multiple applications, which of course by necessity will have to run in multiple applications or in multiple processes. And so you can take a look at this nice article by Lars Vogel, who talks about SQLite and content providers and how to access them. That's a good place to go for some information about that. Some other things that content resolvers do is they provide additional services, such as change notification using the observer pattern. And the observer pattern is a gang of 4 pattern that allows various objects to register for notifications that occur when state changes in a subject, and the observers are automatically notified. And you can do the same thing with content providers via content resolvers, and you can basically have the content resolver notify your application when something happens. And that can be a way to update a view or indicate something to the user that something is available for their use. And of course, the other thing that the content resolver does, and to some extent the content provider as well, is it abstracts away the details from how the data is actually stored. So how do you store the data under the hood? Do you store it in SQLite? Do you store it in a file? Do you store it in a server over the internet? Do you store it in a hash map? Do you store it in a shared preference? That would be kind of odd. But the point is that you can store the data in all kinds of different ways, and the content provider and content resolver abstract away, by and large, from how things work. They just let you access the information in the way that you see fit. There's each activity, each context has a way of getting its content resolver. And so if you have a context, you can simply say to the context, get me the content resolver for this context. Here's typically how you do it if you're in an activity. You say get content resolver, and that gives you back the content resolver proxy. And then you do operations on the content resolver, like insert, delete, update, query, and so on. Here's just a couple of steps that are shown when you query through a content resolver. That takes an argument, which is what's called the URI, and extracts the authority from the URI. The authority is basically something akin to sort of the host name in a URL. It basically indicates the entity that has agreed to handle this type of operation, this type of content provider. So it's basically the symbolic name of the content provider. And then the content resolver directs the request that was made, like a query in this case, to the content provider that's registered with that authority. And then in this case, if it's a query, the query is performed by the content provider, and a cursor is returned. A cursor is basically an iterator that gives you a view into the data, and it allows various optimizations to be performed about how the data comes back, and you can sort of iterate through the cursor and get each element that was returned. If something goes wrong, of course, an exception is thrown. Okay, let's talk a little bit about content URIs, because that's very important, and then we'll take some questions. So a URI is basically the way in which you access content in a content provider via a content resolver. And any URI that begins with content : / is a scheme that indicates that it's representing a resource that's managed by the content provider. So here's an example that comes from Android's contacts support, and this is the photo manager mechanism of contacts. And you can see here we have a content URI. That's the entire thing you see there that starts with content : //. The content part basically just indicates that this is a data that's going to be managed by a content provider. So it's kind of like HTTP : //. It indicates what protocol is going to be used. In this case, it's the content provider scheme. We then have the authority, which indicates who the actual content provider implementation is, and that, of course, would have to be registered with this name. So this is going to be the contacts authority, and that gets you to the right place. And then there's a path, and the path basically indicates the type of data to access. And this will, of course, be interpreted by the content provider implementation any old way it sees fit. So this is kind of like the part of a URL that's the path portion. After you have the portion that's the host name portion, there's sort of a path portion, and that finds the appropriate content on the server. This finds the appropriate table, typically a table in the database. And then finally, there's an ID, which is the specific record that's being requested. So that'll get you to a specific row in a specific table. So that's kind of how the URIs work. We're next going to talk about operations on the content resolvers, and I'll show you some examples. But before we do that, let's go ahead and take some questions, because people have a lot of questions. All right, so question number 1. Are the concepts applicable, the concepts in Spring applicable for other web application frameworks like Ruby on Rails? That's really a good question to ask on the discussion forum, because Professor White is the expert on cloud computing environments. So ask that question for him. I don't have much knowledge of either Spring or Ruby on Rails, so he'd be a good person to ask that question for. We'll be able to showcase the post links that are in your slides. Let's see. I'm not quite sure what Corey is asking here. So you should, I'll be uploading the slides, of course, to everything like I always do. So there's no surprise there. It's the same way it's been done the last other 2 MOOCs. So you can click on them directly. And if people want to update the wiki like you did last time in order to have the links, the hyperlinks in the lectures, please feel free to do that as well. Honestly, I'm not really quite sure what question you're asking, Corey. How does the content provider notify the content resolver that data has changed? You'll see how we do that. We'll show you some examples. There are actually some examples up on the website I'll talk about shortly, and I'll show you probably next week in more detail. There's a method that you can call that basically notifies that notifies the content resolver that data has changed. I think it's called notify change. You'll see that a little bit later. There's a question. The uploaded videos for Professor White are already up on the course. Yes, I just showed you that a few minutes ago. Those are all the videos that have been uploaded. Those are all Professor White's videos. Of course, we will upload other videos as we create them, but all of Professor White's videos have been uploaded. Question about content providers and thread safety. So if content providers are not thread safe, how would you achieve thread safety? Well, there's all kinds of ways to do that. We will talk about them, of course, and I'll show you examples, or you can look at the source code that's available in Android. But in a nutshell, basically what happens is you can either use synchronized statements, just like you would normally use, or you could use some other mechanism that you might want to use, like concurrent hash maps if you're doing something like that, or you could use reentrant locks. You basically do whatever you want. There's no real surprise there of how you implement concurrency. That all the things we've talked about before are useful for doing concurrent implementations. Or if you just are using SQLite and you don't store any volatile state in the content provider, then the SQLite database operation should work perfectly fine for you. Let's see. Showcase is part of Google Hangout for sharing links. So I don't know anything about Showcase, and I don't know how that's going to work. So we're going to probably just go with what we're doing right now. Let's see. There seem to be a few delays here. Will there be any optional assignments in C++? No, there will not be officially any assignments in C++, although I do have some assignments I could put up there if people want to do them, but they will not be part of the course. Let's see, another question. We did a lot of persistent storage in file and shared preferences with downloading images. So what is the decision criteria to use content providers above direct file storage? Well, the main reason for using content providers, of course, is that they are a front end to SQLite and the ability of SQLite to do things like powerful queries and other SQL operations. And those are much more powerful, of course, than you can ever hope to do with files or shared preferences or things like that. So typically, if you're trying to store data where you need to be able to query it, then of course you want to use SQLite. And if you use SQLite, then you want to use content providers. We kind of just used files in the previous courses because I didn't want to have to teach SQLite and content providers till this course. But in reality, you would much more likely have used SQLite and content providers earlier, just that we didn't have that covered yet. In the case if content provider is used for web located data, what's the workflow for content provider to notify an app that the data has been changed? Typically, whenever you do an update, whenever you insert something, whenever you update something, whenever you delete something, you should be obliged to call the notification change method, and that way the application is welcome to do something about that. But it's up to the application, of course. If a person didn't complete the MOOC on concurrency and communication, will they be able to follow the material? Yes and no. There's a lot of stuff that we are using in these assignments that build on what we covered in the previous MOOCs. Of course, all that material is available online, so you're welcome to go and look at it at your convenience. But there's an expectation that you know things like async tasks. There's an expectation that you would understand threading, and but you're welcome to try it. Certainly no problem with that. Is there a specific pattern that content providers are an example of? So basically, they're essentially there's several patterns that they're using. Of course, the content resolvers or proxies, and they're providing structured access to data. There's a pattern, I think it appeared in the Post of One book, called the manager pattern, and a content provider is basically a manager of data. And then there's also, of course, just tons and tons of patterns from enterprise structured data management that you might want to take a look at. There's a book by Greg Hopp called Enterprise Patterns, or Enterprise Software Patterns, or something like that, that talks about a lot of those kinds of patterns. Let's see. So there's a question about the YouTube links containing videos about HTTPS and OAuth, which are not part of these lecture videos. The material related to security and OAuth and so on will be covered in the last MOOC, the last main MOOC in this specialization, which is on mobile and cloud security. Surprise, surprise. So that material will be covered there. Naturally, if you get impatient, you can always watch them on YouTube. Has a content provider its own life cycle? Yes, it has its own life cycle, and we'll talk about that. It gets created, and we'll also talk about how it's accessed. It's accessed like an activity or a service through basically directives that you put into an SQL or into an Android manifest file. Do upload assignments even if it's offline? It's fine. I don't understand that question, Harish, so please rephrase it. Let's see. How does the content resolver talk to a content provider? Does it use the binder framework? So it really depends on whether or not, well, yes, it uses the binder framework, and it works, of course, depends on whether things are co-located or whether or not they are running in a separate process. We'll talk more about those topics when we get a little further along. Let's see, I think we're running down here. Seems like a lot of these questions, there we go. Will you have the chance to communicate with Professor White during virtual office hours? That's a good question. We'll see. I don't know. He runs his own schedule, so I will let him decide. Okay, so that was the end of the questions. Those are good questions. Let's now go and we will reshare our screen again. And now we're going to talk about operations on content resolvers. And this will also give us a chance to talk about some examples. The next topic is operations on content resolvers. In addition to talking about the operations in general and just outlining how they work, I will also show you some examples from an application that I've loaded up into the GitHub site that we're using for this particular MOOC. So you can see this particular MOOC is hosted in a slightly different place, but you can access it easily. It's available from the course website. And one of the examples is something called Contacts Content Provider Simple. And we'll look at that in a little bit. Basically, it's an application that allows you to insert, query, and delete a group of contacts. Okay, so when we look at those examples, you'll see that there's certain operations that are typically done from the application to a content provider via content resolvers. One of those operations is insert, probably one of the most fundamental things. There's actually two variants of insert. There's this version of insert, and then there's also something called bulk insert. We will look at both of them later on in the course. Insert basically takes a URI, which indicates a table, and it goes ahead and inserts a set of values in a row in the table at the given URI. Of course, I'm using the word table here loosely. It doesn't have to be an SQL table. It could actually be a hash map or some other data structure, but think about it logically as a table. If the content provider implementation supports transactions, the insertion will be atomic. You, of course, are responsible for coordinating and controlling that. And then the implementation is typically obliged to call notify change, the implementation of the content provider, after the insert occurs, so that anybody who's wanting to know if something's changed can be notified automatically by the content resolver via the observer pattern and the content observer. And it gives this, what it gives you back is the URI of the newly created row. So then you'll have a way of specifically being able to access that particular item in the table. As I said before, there's also a bulk insert operation, which we'll talk about later, and it takes in an array of content values, and it can be used to atomically insert a group of entries in one fell swoop, which is usually much more efficient than doing them one at a time. Another thing that you can do is you can delete data from a content provider using the delete method. This is a little bit more interesting than insert. Basically, it gives the URI of the row to delete, and you can either indicate the row, in which case it will delete the specific row if you give the ID of the item you want deleted as part of the URI, or if it just indicates the table, then you can use various other parameters to indicate what you want to have deleted. And those are indicated via the where clause, which is sometimes also called selection. And the where clause basically is an SQL where clause filter to apply to the rows before deleting them. And you could also provide a set of arguments that are provided to the where clause, so you can have wildcards that occur in the where clause that can be filled in with specific values. And we'll look at some examples of this. This is a very powerful feature because then you can go through and do things like, delete all entries in the table whose time has expired, or you can look up things by various properties. So you can do very sophisticated kinds of searches for deletions as opposed to just deleting things based on a particular entry or a column, like a name or an ID or something like that. Another very interesting operation, and we'll actually take a look at this one in just a second, is the apply batch operation. This is kind of like batch insert, except you can do arbitrary operations. You can do inserts, deletes, updates, and so on and so forth. And so this is really the most general way of being able to apply operations to a content provider. And when it's done, it gives you back a content provider result array with all the operations that succeeded in being applied. I'll show you an example of using this here when we look at the example application. Another operation you typically do is to update, which allows you to update a specific row or rows that you have selected in the table with a set of values. So basically what you can do here is look for something that you want to update based on a where clause and the selection args, and then go ahead and update those values. So it doesn't change, it doesn't remove the rows from the table, it just updates selected content of the rows. And it returns the number of rows that were affected by the update. And then the most interesting and powerful and complicated mechanism in a content resolver is basically the query operation. And that, of course, is used to retrieve data from a content provider. And if you implement the content provider using an SQLite database, then it will go ahead and retrieve that using SQL operations. And it gives back essentially an iterator over the result set. So it'll give you back something that you can use to access every element. Now, as you can see, there's a bunch of different fields that are provided here. There's the URI to query. You can have the list of columns to put into the cursor. If you give a null, that means you want all the columns. You can also give criteria to indicate which rows that you want to have put into the cursor, or a null means put all rows. And then you can have selection arguments, so you can have parameterized values that are passed into a selection string. And you can also do other things like sort the elements in the cursor in a particular order. So you could sort it by the rows, by various columns in ascending or descending order. Here's basically a mapping from the parameters in the query to an SQL query, which of course would be done under the hood by SQLite. So the URI basically is used to indicate which table you're indicating, you're referencing. The projection is an indication of which columns you want to include in the cursor that you return. The selection is the where clause. Selection args doesn't really have an equivalent in SQL, but it's a common thing when you're programming access to SQL to be able to replace these placeholders in the selection clause with actual values you want, so you don't have to hard code the strings. And then you can also order the results by various columns. And so you can basically think of the URI as a way of indicating either a table or an individual record in the table, which is basically a key. Okay, so to summarize this discussion, and then we'll look at the example, content providers allow applications to access structured data. They're always accessed via content resolver proxies. Often, it's used to access persistent data, although that's not required. In most cases, the persistent data is stored in an SQLite database, though that's not required either. Applications are allowed to share their data with other apps or not. That's controlled by a directive that you give when you create the content provider in the Android manifest file. By default, of course, application data is private. So if you want other apps to get to it, content providers are a good way to do that. And of course, you have to define the content provider in the manifest file. And so this is how you do it. You have a provider directive, which basically says what the name is, and then it gives the authority for this thing. And that's used, of course, to find the actual implementation that you're going to need. Okay, so that wraps up the slides I wanted to present today, just kind of giving you an overview. Let's now go ahead and take a look at the example. Now, before I do that, let me bring up my browser and show you where to find the examples. So we're putting the examples up, of course, as the course goes on. Whoops, I think I just shut my browser. Hold on a second. Oh, here we go. There's the browser. Okay, so if you go here to the website and you come down and you click on FAQ, then you'll find the FAQ. And if you go in here, it'll say something about, where do you find the examples? Let's see, where is this? Here we go. So the mobile cloud repository can be accessed here. This is the mobile cloud repository, and we've got two different places for stuff. We have the examples that Professor White uses for his material, for his videos, and then we'll have the examples that I'm going to cover in the live lectures. And there are several that are up here. This is the one we're going to cover right now. This is Contacts Content Provider Simple. There's a couple of other ones in here as well that we'll cover next time. You might want to wait until next time to really look at them in detail, because we're still doing a few tweaks to them. This one here is actually very much related to the first programming assignment we'll be putting out. And this one is just a fun one that illustrates some interesting aspects of content providers accessed via a content provider client. But this is the one we're going to look at first. Contacts Content Provider Simple. So let's go over here and we will open up our good trusty Emacs editor, and we'll make the font bigger. And there we go. So here is the application. So this application is the Contacts Content Provider Simple, and it illustrates a number of different ways of accessing content providers from content resolvers. If you take a look at the manifest file, you can see that we have one activity called Contacts Activity, and we've also given permission or asked for permission to read, write, and get contacts and accounts. So that's basically what this thing does. Let's go down here and look at the source code. So as is our typical convention, we have the source code split up into several packages. We have the activities. In this case, there's one activity. We have the operations, several operations, as you can see here. And then we have the utils. Now, the utils has got some really cool, interesting new stuff in it. And I will go through and explain all of this stuff as the need arises. One thing that we have is this really cool thing now called a generic activity, which can be used to automatically handle rotations with very little involvement from the user, which is kind of cool. We'll talk about that. We also have a generic async task framework, which is kind of cool. Can make any class run cleanly with an async task without confusing a lot of things. We have our retained fragment manager, which we've talked about before, which is used to store information in a retained fragment so it survives runtime configuration changes, et cetera, et cetera, et cetera. So we'll come back and talk about this stuff shortly. Let's start by taking a look at the contacts activity. And as always, we're not just here to talk about the specific features of Android. Of course, we will talk about the specific features of Android in terms of contact resolvers and accessing the contacts content provider, but we're also trying to show how to write clean Android applications that are easy to understand and easy to maintain. So here, the contacts activity is a generic activity that's going to have a contacts ops as the object that will actually implement the business logic. And I'll show you how this works later. It's really, really cool. It makes the management of runtime configuration changes almost completely transparent to the users. We're going to have a list view, which will be used to present the contacts list when we query it. These are the columns we want to select out of the contacts content provider that Android provides. We want to get the ID and the name. Those are the columns we're going to display. We also have the resource IDs of these columns, which is a string and a name. And those things, of course, are defined as resource IDs, which we use when we want to display stuff through a list view. We have a simple cursor adapter that's used to actually view the results. If you download and run the application, you'll see what it does. It just displays the contacts that we've inserted after when we query them. Here's the onCreate method. This, of course, as you all know, gets called back when the app gets created. The first thing we do is we set the content view. Then we go ahead and initialize the list view. We make ourselves a simple cursor adapter that starts out showing nothing. Its cursor is null to begin with. And we make that the adapter that the list view will use to present the results. And then we do a little cool magic. The superclass of contacts activity is called generic activity. And it has an onCreate method that's ever so slightly different. And this onCreate method not only takes the save instance state, but it also, if any, which we don't use, but if there is any, it'll take it. And we also use we pass the class that we want to be the operations class for all the methods that are defined as buttons for the user to click. And this follows along with a pattern we've been using in all the other MOOCs, where we separate the user-facing operations in the activity for input and output, and then all the actual business logic resides in an ops object or an ops class, which stands for operations. And now we've just made this a little bit more transparent and invisible. The cool thing about this is if you use this technique, there's basically nothing else you have to do to handle runtime reconfiguration changes other than define a hook method we'll look at later. When someone clicks the insert contacts method, it goes ahead and grabs the ops object that's managed by the generic activity framework. So it grabs the contacts ops instance and it calls the run insert contact command. So that we'll look at that. When someone queries a contact, we run the query contacts command on the get ops object. And when someone runs the delete contacts button, when they click the delete button, we run the delete contact command. And that, of course, also works on the contacts object. And the last thing we do is there's a method for displaying the contents of the cursor. So when we're all done with a query, we can display the cursor and we can go ahead and reset it to what we want it to be. And that will automatically populate the screen with whatever, the list view with whatever we've given it, which could either be the query results or could be null if we want to make the list view disappear. So that's all there is for the activity. Again, the idea here is to keep the activities really clean, really concise, not make them cluttered up with a lot of business logic. They're really handling input and output related kinds of things. And again, this automatically handles screen rotation in a very, very cool way. We'll talk about later. Here's the operations. This is the business logic. This is the stuff that actually does the real work. Here is contacts ops, which is the operations that we want to do on contacts. And this implements the configurable ops interface. Configurable ops is defined over here in the utils directory. And all it does is it defines an onConfiguration hook method, which basically serves as a virtual constructor that is called back when the contact ops object is first created, as well as any time the configuration of the device changes. And we'll take a look at that in a second. We define a tag that keeps track of the debugging information. We make a weak reference to the activity, so we don't have to worry about garbage collection. We also define a bunch of other little fields here that are used for managing the account that we're going to use for our Google account. We'll talk about that a little bit later. We have the cursor that we use to keep track of queries, the most recent queries, so that if we do a runtime configuration change, we can redisplay the list view cleanly. Here's the list of contacts we're going to want to insert. This, of course, is just for fun. A real application would prompt the user to enter the contacts. I'm just having a good time with people named Jimmy or some variant of Jimmy. So this is a list of contacts. Here's the constructor. As you'll see later when you look at the generic activity, you need a default constructor that does nothing. It just needs to exist. So we define it as public. Here's the onConfiguration hook method. This gets called when the contacts ops object is created by the generic activity. And what it does is it takes the activity that's passed and it has a first time in flag. It stores the activity in a weak reference. And then if it's the first time in, we initialize the account information. And if it's not the first time in and the cursor that we saved is not null, we display the cursor. And that just makes sure that if we have a runtime configuration change and we have a query results on the screen, those will show up after we rotate the phone. So this is basically serving as a virtual constructor that handles rotations cleanly. The other operations in here basically use the command pattern. And so here's run insert contact command. It zeroes out the display of the list view so it doesn't show anything while we insert new elements. And then we go ahead and we make a new insert contacts command, passing in the list of contact names we want to add, and then we run that command. So this is basically the command pattern. In this case, I'm running these things basically synchronously, but there's no reason why I couldn't queue up these commands and run them later if I wanted to, because after all, they're commands. Here's the query command, works basically the same way. We make a new query contacts command object and run it. And then here's the delete command. We run a new delete contacts command, passing in the iterator of strings we want to delete. So that's basically the operations. As you can see, the command pattern figures in very prominently here. We'll take a look at how this works. Here's how we initialize the account. This assumes that you've got a Google account that's configured on the device. That's not too hard to have if you're doing Android, of course. So it initializes the account. And then we have some accessor methods that we can use to get the various fields. We can get the activity, and we can also set the cursor. So you'll see these things are used by the various command objects in interesting ways. All right, now finally, let's take a look at some real code that uses SQLite. So, or sorry, that uses the contacts content provider, which uses SQLite. So here's the insert contacts command. Insert contacts command is a generic async task ops. It implements the generic async task ops interface. This is the interface. It's a really cool little interface that I defined, and it basically defines methods do in background and on post execute, which mimic the ones you would have if you had an async task. And the reason that we do this stuff is because this allows us to be able to delegate the processing that goes on in the background to the command class itself, rather than having some awkward dance between the async task and the class that we have. And you'll see how this gets used in a second. It's really cool. Here's a contacts ops object that we stash away so we have access to its fields. Here's the iterator that we're going to be iterating over, or to insert. Here's the generic async task instance called masync task, which we parameterize with the various fields that we want here. Here's what generic async task is. It's a very simple implementation of async task, which basically stashes away the operation, and then which is assumed to implement the to extend the generic async task ops interface. And then its do in background method, which gets called in the background in a background thread, simply forwards to the ops do in background method. And likewise, on post execute forward to the ops on post execute. And the reason for doing this is it greatly simplifies state management, because the calls that are taking place are actually occurring in the context of this class rather than in the generic async task, in the async task. You'll see how it cleans up the code quite a bit in a second. Here is the constructor for insert contacts command. It goes ahead and stores the contacts ops in the iterator, and it makes a new generic async task, passing itself in as the ops object. And then here is the run method. When run gets called, we go ahead and we execute the async task, passing in the contacts iterator, and that will turn around and call the do in background method that we have here, that we implemented from the generic async task ops interface. And then we go ahead and we insert all the contacts. So notice how this is all taking place in the context of the class, rather than having to be pushed back into the async task itself. Async task is simply being used to run things in the background. So we'll look at insert all contacts in a second. That obviously does all the heavy lifting here. Here's the on post execute. When we're done inserting things, we take account of the number of things we inserted and we print that as a toast. And by the way, the reason we're doing this stuff in the background, in a background thread, is we might have a large number of things to insert, so it might take a while. Just to illustrate that. We don't have to do it in a background task, but we're just showing how to do it that way. Here's insert all contacts. This goes ahead and makes an array of content provider operations. And this thing is called batch operation. We iterate through all the contacts that were passed in the contacts iterator, and we add each contact to this array list. We'll look at that in a second. And when we're all done, we then have an array list of batch operations. And then we go ahead and we call the content resolver, and we apply all of these batch operations to the contacts content provider, which is the authority. This is the Android content provider that manages your contacts. So we just added a bunch of contacts to the content provider. This is running in a background thread, of course, because it's called from the context of do in background. And to avoid all kinds of nonsense and headaches with things changing out from underneath you, we just go ahead and grab the application context and use that, because that won't go away if the activity rotates. This returns an array of content provider results, and you'll see in a second, for every contact, we have to have 2 operations to insert it properly. So we take the length of the results and divide by 2 to find out how many things we actually inserted. Here is the add contact method. This really does the low-level interaction with the Android contacts content provider. This code that I'm showing you here is actually explained in more detail in the Android documentation for raw contacts. It actually explains what's going on. What we're doing here is we're basically taking in a list of content provider operations, and we're adding 2 new contact provider operations to that list. And again, this is just the kind of craziness you have to do if you want to insert things into a content provider using Android's contacts content provider. So we make a new operation that does an insert. It's going to go into this location, and we insert the raw contact first. So we create a raw contact using this approach, and we use the builder pattern to do that. And notice we starred this thing. We added as a starred contact. That'll be important in a second when we do a query. And then we go ahead and we insert the raw contact into the actual content URI for the contacts content provider. And that goes ahead and goes back 1 and grabs the raw contact data that we put here. And then that goes ahead and stores that in the contacts database. And again, go and take a look at this link if you want to find out all the details. But the bottom line is this is basically using Android's content resolver mechanisms in order to be able to create a list of content provider operations and then applying that list in a batch way to insert a new contact into the contacts content provider. Now, mercifully, that's done for you by Android. The contacts content provider is done by Android, so you don't have to know how that works. You just have to know it works. You don't have to know how it works. It's very, very complicated. Let's take a look at query. Query is kind of cool. So query does the same thing. It's a query context command, which implements generic async task ops. And we list the columns we want to query, which are going to be the ID, the display name, and any contacts that are, quote, starred, which are marked as important. Here's the actual the select argument for the where clause we're going to use. And you can see here we're going to query for the display name, and we want to have the display name not be blank, and we want the column to be, we want the contacts to be starred. So basically what we're saying is here, we want to look up the display name. We're going to query for the display name that's not blank and anything that happens to be starred. That's what it's going to be looking up in the content provider. And here's how we do this. The constructor works much the same as before. We store the ops as the sort of the generalized context for this. We make an async task. The run method executes the async task. Here's the do in background method. This runs in a background thread. This could actually take some time, so that's why we do it in the background thread. We query all the contacts, passing in the content resolver. And when everything is done, if we manage to get anything, we will make that the cursor and display it. Otherwise, we will simply print a toast saying there was nothing to be found. Here's the actual query operation. It's very simple to do, but of course, it's very powerful under the hood because it's using SQLite. We go ahead and we tell the content we tell Android this is the content provider we want to reference. This is the contacts content provider. Here are the columns we want to query, which were these columns right here. Here's the where clause. We want you to select anything that's not null and is starred. And we want you to go ahead and sort the result in ascending order by the ID, by the ID of the contact. So when that runs, of course, it'll return a query, and that query then, or it'll return a cursor. That cursor comes back from do in background, goes to on post execute, and then that goes ahead and gets displayed. So that's how we're going to display that. So that's how we do a query. And then the final thing we're going to show is the delete contacts command, which implements the generic async task ops and runnable like everything else. And we keep track of the contact ops and the iterator for the string of contacts to insert. We have an async task. The constructor looks the same. The run method looks the same. Here's do in background. This deletes all the contacts that are listed in the iterator. And when that's done, we pop up a toast that says how many contacts were actually deleted. And here is the delete all contacts operation. Now, this is kind of an interesting one. What this thing is going to do is it's going to loop through the iterator, and it'll call delete contact for each element in the iterator. And then delete contact, as you can see here, will simply go ahead and get the content resolver from the application context and then call delete. And what it's basically saying here is it's saying, go to the raw contacts database, the table, find any row whose column, whose name column matches this name. So this is kind of that wildcard flag that you can pass in. And this is basically the selection arg. So this is called selection, or the where clause. And these are the selection, this is the selection arg. And we're going to go ahead and remove anything that has that particular name. So that'll go ahead and take everything out that has that name in there. We, of course, could have made this more interesting and more robust. We could have only deleted things that were starred contacts, and then we would have had a more complicated selection clause here in order to be able to just indicate things that had a name and had the starred attribute, and so on and so forth. So that's basically it for the application. You can see it's very clean. Everything is kind of in its place. It uses a bunch of interesting patterns. The command pattern is used. It, of course, uses a bunch of Android features. Let me talk briefly about the framework that we're using here. So this is something that's new since the last MOOC. If you go back and look at the old stuff from the old MOOC, we had a different way of doing this. This new way is way cool, much cooler than what we did before. So we now have something called a generic activity. A generic activity is a framework that basically, if you use it, will automatically handle runtime configuration changes in conjunction with an instance of something called ops type, which has to implement the configurable ops interface. And it also inherits from lifecycle logging activities, so everything's logged. So a generic activity contains a retained fragment manager. As you recall from the last MOOC, retained fragment manager is used to ensure that you can put objects in a storage location that will survive configuration changes if the phone rotates. We then have something called ops type, and we have mops instance, which is an instance of ops type, and you'll see where this comes from in a second. Here's the onCreate method. It calls up to the superclass. It also takes a class of ops type. So it takes an object of class. It calls handle configuration, passing in the ops type, and hopefully everything goes well. If not, an exception is thrown. Here's handle configuration. What this thing does is it goes ahead and it checks to see if this is the very first time the application has been called, because in that case, the first time in flag from the retained fragment manager would return true. If it is the first time in, we initialize everything using a call to a method that will initialize stuff based on the ops type. Let's go take a look at initialize. Initialize uses the class object to make a new instance of ops type. So it dynamically creates a new object of type ops type, and then it stores that object into the retained fragment manager at this name, which is whatever the name of the ops type is, and this instance. So now that is stored in retained storage, which means it will not be destroyed when we rotate the phone. And then we go ahead and we call the onConfiguration_hook method on this new instance, saying this is indeed the first time in, and passing this activity in as the initial activity. So that's basically how that gets done. That's what happens the first time in. If this is not the first time in, then we go ahead and we retrieve from the retained fragment manager the mops instance using the simple name of the ops type to get it. And that should be non-null. So let's ignore the case where it's null. That's a pathological case that occurs under some conditions, but it's very rare. If it's not null, then we go ahead and simply inform this object that the reconfiguration has occurred, and we pass in a false, indicating this is not the first time in. So this is a really cool little framework that greatly cleans up a lot of stuff that was kind of ugly before. And as a result, to make something work with this model, all you have to do is inherit your activity from generic activity, pass in the name of the class that you want to use as the ops object, and then you simply pass in the class type for that ops object, the onCreate method. And after that succeeds properly, then you can get the ops and everything will be set up for you. And all the ops object has to do then is simply implement the onConfiguration_hook method, which, as you can see, will do the right thing, whether it's the first time in or some subsequent time in. Anyway, this, of course, is not strictly necessary to use all the contact stuff and the content provider and content resolver. But for the applications I'm going to be using in this course, we'll be using it as a way to keep everything really clean and neat, and yet have it automatically be able to handle reconfigurations without having to do anything special. Okay, so let's go ahead and take some questions. How much space does my app have in its content provider? I don't think there's a limit. You can put as much as you want in there, up to the point where you run out of resources on your phone, or on your device, that is. Let's see. Isn't a weak reference cleaned out every time garbage collection runs? Yes, indeed. That's exactly right. And that's exactly the point. So the recommended way of being able to have objects with dependencies on activities to ensure that the activities are properly garbage collected when rotations occur is to have the objects that depend on those activities hold weak references to the activities. And if the activity gets cleaned out, then that weak reference get method will return null, and there'll be a null pointer exception, which of course you need to be careful to either catch or prevent. And the little generic activity framework I just showed you illustrates how to do all of that. The generic activity framework, if you follow the callbacks properly, then as the phone is rotated, and you update your activity weak reference inside of your ops object properly, then you should really have little or no problems with things disappearing out from underneath you. This turns out to be one of the many subtle and mysterious features of Android that are not well understood, and we've been working over the past several MOOCs to come up with a really clean framework and a pattern language for making it as easy as possible to deal with these kinds of issues. And I think we're getting pretty close. We're not 100% there, but the frameworks that we've come up with in the last couple months greatly simplify the management of state in the face of runtime configuration changes. And it's really pretty cool. Okay, are there any other questions? If people have questions, feel free to ask them. I'll just kind of wrap up a few things here. So keep in mind the following. the first assignment and the first quiz will go up later today. I need to do a few things to just double check everything before I put them out. As usual, they'll be due in 2 weeks from their release. We will have 3 assignments in the course. As I mentioned before, the first 2 will be sort of skeleton based, where we leave out some details and you get to fill in the details. On Friday at the virtual office hours, I will go through the assignment, and I'll also go through an example application called the Weather Service Provider that is similar, though not identical, of course, to the first assignment. And you'll get a chance to see how all that kind of stuff works. The last assignment in the course will be a mini project where you'll be able to do it basically from scratch. So just another little note. So the first assignment is going to have you predominantly doing the client side programming. You'll be using retrofit to access the contents of the web service, and you'll be using a content provider to store the results in a cache. We'll talk about that on Friday. The second assignment will have you actually implement the web service. So you'll actually be implementing the web service and doing the various things that you need to do in that case. And then the third assignment will be something where you'll do both. You'll implement the service, and you'll also implement the client. And for the second assignment, we'll give you some auto grading scripts so you can hopefully test out your server without having to have a client written by you. And then in the third assignment, you'll actually write the client. Are there fixed days for virtual office hours? Typically, the virtual office hours will be Wednesday or Thursday. They will be Wednesday probably next week, and then the following week they'll be on Thursday, because we always try to do the virtual office hours, as you know, the day after the assignments are due, so I can go over my solution. This week, the virtual office hour is Friday because for some odd reason the course started on Wednesday. In future, we'll try to make the course start on Monday, which is a little easier, and then we would have a more normal schedule. But they'll follow essentially the same pattern that we did in the last 2 MOOCs. Shouldn't be many surprises. I, of course, will post the announcements on the announcements list, as well as putting them on my Google Plus page. Okay, well, if there's no more questions, thanks for joining, and I will upload the videos and post-produce them sometime later. Thanks very much.